We're going to have a chance to explore AnyLogic quite a bit more over the course of this boot camp, but we have you'll be happy to realize that we have addressed what I consider the core features of AnyLogic when it comes to agent-based modeling in particular over the past 4 days. And really it was Tuesday, Wednesday, Thursday. We did the heavy lifting. We introduced constructs as varied as events and state charts and statistics, populations, classes of agents. We introduced output mechanisms such as time plots, and we introduced variables and parameters, and we saw that they could interact and be used fruitfully together to achieve something where, fittingly enough, the whole is greater than the sum of the parts, where we can have quite rich models built with an economy of mechanism that's actually fairly striking compared to what's traditionally been required for agent-based models of comparable richness. Now, these models that we built up yesterday tapped into a component of that canon of increasing importance and of a lot of interest, and that is geographically situated and grounded models which draw on geographic information systems databases to dictate the placement of resources in the model. Think parks, convenience stores, supermarkets in yesterday's model, but in other models we build it's been clinics and hospitals and methadone distribution locations or what have you. So that's one way in which GIS informs the models. Another way, arguably even more fundamental, is by allowing us to shape agent behavior in the models per the dictates of the geographic constraints. So this might involve routing agents over bridges rather than naively having them diffuse across a river. Having the agents confined to the loopy suburban street patterns that you see in many cities in North America, rather than being able to go more directly from A to B. Walkers have to sort of wind around and wend around in a way that discourages physical activity. We saw that we could use GIS-type systems to reason about the possible paths from A to B across many different routes, many different modes of transportation, and indeed routes as well. And that can then shape behavior in as much as we represent agents as situated decision makers with limited knowledge, perhaps, but making decisions about their routes to go to work or to present for care, and making decisions accordingly. So perhaps it will be deciding whether to do a quick milk and bread run over to the convenience store across the street, or to have to go, get on the bus that comes once every half hour and take it up to the supermarket in northern Saskatoon or what have you. So we can reason with GIS databases about factors that shape this decision making and that shape the outcomes of the decision making. So I noted and emphasized the point that in GIS grounded models, and indeed as in discrete event models commonly, the timing of of an agent's movement, how long it takes them to get from A to B, it's not something we hard code into the model. It's not something we hardwire in to sort of cause there to be this time between A to B. Rather, it's something that emerges from the model in the sense of an emergent feature. It's an endogenous feature of the model that is produced by virtue of the route and the route's characteristics, potentially concerns about traffic that might be introduced, but certainly something about the agent's speed in traveling. And that allows us to abstract away from a lot of vagary of details about wanting to capture precisely the timing that different agents spend in transit or would spend in transit, and allows us to go up a level of abstraction and just talk about routes and speed of movement and so on, and have the system calculate for us the timing. That's not a small matter. When we consider this for discrete event modeling, this kind of process-centric modeling where we have workflows depicted that are resource constrained, the endogenization of travel times within that, the fact that within that model we will simply say, get this doctor, to the procedure room, or have the nurse move some equipment from the storage to the operating theater. The fact that that's the level at which we operate, rather than saying, okay, the nurse spends exactly this much time in transport, allows us to ask what-if questions that are significant. Remember, when we build into our models as endogenous quantities certain causal pathways, to have those things calculated by the model, that gives us extra flexibility for certain types of intervention. So if we want to ask, for example, how would the placement of a clinic within a city affect care-seeking behavior by individuals? Or at the micro level, if we want to ask, how would the placement of that equipment room in the hospital shape, how nurses spend their time and the workload on nurses within that facility? That's going to be tied up with that placement. And by having the model calculate the transit times and the fraction of time spent in this task or that task, we can actually secure great advantage, because we can ask these what-if questions about placement of resources or level of resources, and understand how it ripples through to how the time is spent, or the likelihood of someone presenting and therefore rippling through to the progress of their chronic conditions, their ability to self-manage, their ability to seek care, etc. So the fact that we can have agents situated at different places, and what's implied there and what the model calculates is the time to their destination, and hence their decision making is shaped accordingly, is a very powerful feature of GIS and indeed of discrete event modeling, that in both cases comes very cheaply in terms of the amount of work that's involved for us. That's significant. And we only touch the surface of AnyLogic's library to support these sort of tools, but I hope it gave you a bit of a glimpse as to what was possible. And we may, depending on participant interest, over the next 2 days, explore this in more detail with additional geographically explicit models. Now, there's a couple other aspects of it that I didn't emphasize yesterday. As Jeff says, every time in the boot camp I have to figure out the 90% not to talk about. And one of the things I didn't talk about yesterday, but whose omission I rued, was the fact that geographic displays, for reasons that Sarah would probably better appreciate than I, being a geographer and someone working in health geography, geographic visualization, geographic displays of model results have a singular, perhaps, from my experience, sort of distinguishing character in terms of interaction with stakeholders. I cannot think of a single other feature of the models that we build that so captivates audiences, so captivates stakeholders, and so seems to bring home to them the essential ideas that we are modeling processes within a system. We're modeling at a mechanical level what's going on in a population. And I lacked the psychological training or the sort of insights into human psychology and behavior and human-computer interfaces to understand this. But Jeff has made similar remarks. And I will tell you that in boot camps where there has been a reserved component of the audience that isn't fully buying into it, they're kind of checking their mail on an ongoing basis and not fully into this thing. They're part of a bigger group, and there's a bunch of keeners, and then there's a bunch of folks who are sort of sitting back and not sure quite what to think about this guy talking to them, or about the content. When I roll out GIS, they tend to get sucked into the vortex, and they get excited. And they'll sort of exclaim in excited ways and so on, with a degree of enthusiasm that was entirely absent, just hours before. And I don't know why this is, but Jeff has also commented that sometimes showing geographical features of a model just enhances your credibility with others. Now, I find that statement at once encouraging, but also sobering and a bit scary. Scary because the placement of certain causal pathways, certain mechanisms into the model as an endogenous feature of the model is not a decision to take lightly. It's not a decision that I just kind of throw it in and say, oh, what the heck, let's throw it in. That leads to kitchen sink models where the model ends up ballooning in its scope, and you have all sorts of extraneous details, sometimes details where there's very little understanding and there's a lot of speculation, but at the same time it's not part of the model as a theory building exercise to explicate this area of the model, but it ends up taking undue time. And that's something which we have to, as modelers, be very careful about. When we're building models, coming back to that first day, when we're building models, we are seeking a simplification of the system so it's a manageable construct, so we can build this model that helps us reason through the system. And over time, perhaps we'll enrich it by adding in features, but it's very important that we start simple. And if we shortchange the process by tossing in some what Jeff has been known to call trinkets for the natives, these extra little elements of geographic information systems, there is a risk here that we're going to get bogged down in discussions or topics which are not really germane to the model in its core form, and they're not germane to the core purpose of the model. At the same time, they may bring along stakeholders that are critical to the success of the model and to turning, as again in the immortal words of Dr. McDonald, that are likely to actually yield a model, not only a useful model, but a useful model that gets used in the end, that actually has the political will and strength behind it to actually see it translated into decision making in a strong way. So this issue of geographic information systems is beyond, it's not one that's merely an interesting feature of any logic, not merely one of many. It's not merely a sort of side issue when it comes to the alphabet out of which we compose our words that form models. It's one that has big implications. And it has implications for stakeholder confidence, it has implications for stakeholder appreciation of what you're trying to do in the first place, and it has implications for the scope of the model project that have gravity to them. As such, I think it deserves particular note. Geographic information elements are ones that increasingly we see demand for. There's no question that it's part of what stakeholders discuss with us at a growing level compared to 20 years ago or 30 years ago. And I have found that many models that I would have previously been inclined to show in a stylized space, I can so easily put it into GIS that it seems like a no-brainer to do that. That model, for example, that I built with the hierarchical cities and so on, probably within half an hour, of additional work, we could have converted that readily into a GIS type model, where those cities that are placed are not randomly distributed squares, but are rather, actually municipalities located within our province, where the links between them are not these sort of very simplistic straight lines, but instead they're real ways, means of travel, real highways or byways within the map, and where instead of asking about the straight line distance, we could ask about elements of actual distance on these roads or what have you, and that would be very easy to do, and that's one of the possibilities for the next 2 days. We could spend more time with geographical information systems, and instead of having convenience stores and grocery stores as points in a model, we could have cities as regions in a model as agents that we would to which we would route individuals or place them, or whose distance to each other we would about whose distance to each other we would reason. Okay. So GIS was important, not as a side note, but as something I think plays an odd role within the modeling process. And I'm just coming to terms with how to effectively build it in, but Jeff also, as usual, has a lot of wisdom, and he's worked on a lot of projects where that has played a role, not only in terms of the research questions, but in terms of the stakeholder milieu. Jeff, do you want to add anything to my crude utterances on that?
No, just the idea of bringing people along. That's really the hardest thing in a project. The modelers tend to move ahead of the sort of the stakeholders, and bringing them along is pretty much the most common mistake. Well, not bringing them along is the most common mistake, I think. Kids making the modelers get excited about their learning, but the others, you have to be there in a room, but they're not. So that's kind of, so really ways to bring them along. So these things that just intuitively resonate with the way they think.
Yeah.
And and again, it's more an emotional than a rational thing.
Yeah. But at the same time, sort of clues them into the basic ideas sometimes of simulation modeling.
Yeah. I think it's just the idea of, as I say, dots moving across the map changing colour, and you just don't need to look at the graph. You don't have to look at the x-axis and the y-axis and work out what's happening. It's just there. There's no explanation required. I think that's really it. But this idea of how do you bring along a group of disparate stakeholders, the old herding cats up a 2-inch pipe. How do you do it? And the problem is you end up then getting a kind of a split in your team. You've got the people who are sort of excited, a core group who are highly engaged, but then there's a whole lot of other also-rans that really you need them to actually make a difference, to get policy decisions based on the modelling actually implemented. So that's really the challenge, and as I say, I think the GIS and this sort of intuitive display of results and what ifs, which you can do with just seeing the different, this sort of crowding on a map that suddenly turns into order. The people queuing in the waiting room at ED suddenly go away. It's just, they don't need to look at graphs of confidence intervals and stuff like that. But again, it's very dangerous because it can end up just being eye candy. We've got to work out the right thing.
Exactly.
Well, the good thing now is it doesn't take a lot of time to do this stuff. Well, in the old days, it used to take a lot of time.
Yeah.
People would be drawing polylines across stuff and importing. It just was nightmare.
Yeah.
So.
Yeah. Thank you, Jeff. Yeah. So that was GIS. I cannot tell you how pleased I am to see many of the projects sort of rolling forward in their various forms. And it is my commitment to you today, and indeed tomorrow, to for those who are able to stay tomorrow, to make sure that we can push these projects along. I would like to, and now I'm segueing a little bit into from retrospection to prospection. I haven't heard that yet, but prospective musing. That looking forward, I would like to actually see if we could reserve a little bit of time for a hint of a show and tell. There's a lot of neat stuff going on, and I have the privilege of sort of moving between groups and seeing it. But there's many people, even the TAs, who are so involved in helping to advance things that probably have little global sense of what's happening and what's moving forward and so on. There's some really neat sort of projects, neat insights that have come from working to build them, but also just neat elements to sort of appreciate how these the scoping of the projects, what the pieces are, what they're starting to look like, etc. And I think there's a lot of lessons to be learned from each other. So I'm going to try to figure out some way that we might be able to do a little bit of a show and tell, to give some at least 5 minutes to allow people who feel inspired to do so to sort of share a little bit what they're going, and maybe even provide a bit of a glimpse, even if it's just a couple state charts or something like that for people in the room. Okay, so that's one thing in my mind. But we have some important priorities to explore. Now, I'd like to get a reminder from people. How many people here will be leaving during the day today? Okay, that's really helpful. It will also help me prioritize my time. And how many people will be here for at least part of tomorrow? Okay, that's helpful. Okay, so that gives us some opportunities for some materials tomorrow. But I will try to prioritize some things today. There's some topics that I want to go over, and some of them are elective, and where I'm going to be seeking votes. Some of them are, oh gosh, obligatory. Close and lock the doors. We're in lockdown now. Now we're gonna teach you all about Java. The hidden secrets. No, don't worry. There's none of that. Okay. So one thing is hybrid models. This boot camp has in fact, in its very title, it has a reference to hybrid models. And one of the big motivations for any logic is the fact that we can weave together multiple models. And in different configurations of this boot camp, I've spent more or less time on this. But I am determined to do a session which will clue you in to some of the most compelling configurations of hybrid models. 5 compelling patterns that I consider almost irreplaceable about hybrid models. Utterly compelling ways it can be used. So we will talk about hybrid models, and in fact I will talk about that next. from this very floor. Okay, within this very hour. Okay, I'm starting to sound like Hegel. Hegel would give these lectures and say, at this very moment, we are undergoing, because of this lecture, a fundamental transition in humanity. Because I am articulating these things. I never really thought too much of that. But anyway, we'll have hybrid models presented. Okay, a second thing which I need to talk about is the community infrastructure in the form of a community contribution website, which we have been in the midst of designing and rolling out, and this is, as I see it, it's going to provide what I hope will be a key nexus for those who attend my boot camps here or worldwide, to communicate with each other, communicate with TAs, hear about events where I'll be giving, webinars or be recording material and different things, can express interest, can ask questions, can learn about funding opportunities, can seek partners for ad hoc work or for more sustained partnership on projects, can exchange kind of resources and pointers to videos, and where I can post my lectures from whatever event in a way that interlinks the video and the slides, and interlinks the example models built, and interlinks any related exercises or challenges, etc. So these two are things that I need to do. Chris needs to know about them, and anyone else will need to know about these things. Go forward. And the thing related to this, about which I have been asked, is the issue of sort of further resources for learning, and those two sort of go together. Okay, where this is kind of the interactive resources here. I'm really excited about this, and I know Jeff is. And we have a first solid foothold now. There's a lot to go, and you folks will be important to shaping it. Okay, so these are some things that I'm definitely going to do. Now, there's a set of additional topics that are really important, and which I would like to hit. And the question is mostly, when do I hit them, today or tomorrow? And these include the following: sensitivity analysis, showing how to perform parameter sensitivity analysis, both one-way, multi-way, Monte Carlo, within sort of defined ranges with your models. And part of what goes along with this is handling stochastics and reasoning about model runs over what we call ensembles of realizations. I mean, we're running the model many, many times, so we're not basing our insights on flukes from the model. So it's a lot of stochastics. Another topic is calibration, and it turns out that these kind of go together. And here you're grounding the model with data, but you're doing so in a way that doesn't directly take that data and inform parameters of the model. Rather, what you're doing is you're matching the model emergent behavior, the sort of the output of the model, as it were, against observed data. That's typically also can't be reduced to any one parameter. That's tangled data. So when we think about something like the prevalence of diabetes in Saskatchewan, you can't take that and directly estimate a parameter of the model, because the prevalence of diabetes in Saskatchewan is itself it's a result of an entangled set of factors involving demographics and involving, and shifts in demographics involving the natural history of progression and the presence of obesity and faster detection systems. It's resulted from an entangled set of features, so we can't use it to just put it directly into a model parameter or two. Rather, we can compare the model results against what's observed from the world. And often, I don't know about you, but when I bring empirical data to the table, often it's data about that's a result of an emergent process. You know, another example, sometimes we make the mistake of thinking data we observe from the world is directly translatable into a parameter. I remember when the world was young and still cooling, and I wore a younger man's shoes, and some of my TAs were probably in elementary school. You know, I had this notion that there was a lot of data out there we could just directly put into the model for parameter values. And things like contact tracing networks, I thought, oh, you know, it tells us about the network structure in the population, you know, the structure of the connections between people. We can put it into our model. No, and you know, some of UN's work, you know, helped really highlight in my mind just how much the contact tracing networks we get in terms of empirical data, wonderful sources of data, but they're the results of an emergent process involving how the infection spreads and how the contacts are followed up and determined to be cases and how their contacts are traced. It's a result of a process, and we can't put it into the model as kind of these network assumptions, but rather we can compare it to the model results to sort of see if our model is reproducing some salient features of the situation. So sensitivity analysis and calibration, ladies and gentlemen, are topics I want to cover. And the question is when. Another one is dynamic networks. Here we are talking about situations where we want to allow people to engage in partner change, or you know, changes in with whom they have contact over time. Maybe they're changing with whom they engage in needle sharing, or with whom they're partnered at a sexual level. Maybe they're changing their collegial relationships. Maybe they're simply going back and forth between two different exposures at work and at home in a way that would expose them to different risks of contracting H1N1 flu. But you know, in the course of the day, the people surrounding me varies at different times, right? So these are dynamic networks. They're quite readily explored in AnyLogic. I know some of you, like Betsy, have quite a bit of interest in this, and they're quite nice to probe. So you know, I'd be glad to talk about that. Another topic is one involving the use of AnyLogic models to output data that was then used in R, analyzed in you know, a SAS, or can be put together in Stata for some nice graphs or what have you, and also models that bring data in from data sources. So I don't know about you, but a lot of my data is in spreadsheet files and databases and you know, files on disk, and I want to get it into the model, and then when the model produces results, I want to get that out. Because AnyLogic is great for some very basic analyses, but there's a heck of a lot of analyses I do where you know, the mechanisms for graphing and AnyLogic and so on would be far too primitive for me to do the sort of to pull together the sort of illustrations I want and so on for a journal paper or what have you. Okay, so ladies and gentlemen, there's sort of model input and output. That's going to be an important topic. And related to this is the topic of AnyLogic databases. These AnyLogic provides, associated with each model, a database that can be used to, amongst other things, create agents within the model. It can be used to record occurrences of events in the model in a very nifty way. And I'd like to have a presentation on that as well. There's some related tools for this as well that are pretty handy, that would be nice to be able to discuss. I have a particular personal interest in this issue of kind of dynamic models and big data, and how I have a paper which I want to share with you folks, and I will share, which involves sort of laying out what I see as something on the order of 5 or 6 frontiers of dynamic modeling. And in it, I argue that the coming decade is going to be, that system science in the coming decade, complexity science, system science, is going to look very different than it did, a decade or two ago. Say that almost 2 decades ago when I started this work in health and system science, and certainly dramatically different from when I first started creating agent-based models, 26 years ago or something. That paper has an important element talking about this linkage, and our work is at the core of this linkage because I do lots of work these days in big data and mobile data collection and for health, and then combining it with dynamic models is one of our foremost foremost uses of the data to inform policy or inform insight at a higher system level. Some additional components here would be implementation science type concerns, capturing issues of scale up of interventions, of human resource and financial needs for interventions, and intervention effects. Talking about how interventions are represented in the model. And I would put in here sort of targeted interventions and their implementation. We have some stuff on that. Interventions, sorry. And then sort of trade-offs. Like, what would motivate you to use discrete event modeling versus system dynamics modeling versus agent-based modeling for certain regions of your model? Given it's not an either or at the level of the model, so this is kind of trade-offs or kind of distinctions and sort of core competencies for the 3 different types of modeling approaches, dynamic modeling approaches. So those are a set of topics that we could cover today and tomorrow. And as I said, some of them are going to be covered. I asked Winchell, who also goes by the very well-deserved name, The King. He is preparing something on any logic databases, I think even as we speak, somewhere through this wall, I think. He's over there hunkered down. So I'll assume that will get done. So I'd like to get votes on these other things, okay? Now the voting, I think I'm going to use the voting to triage in the following way. For the most part, it's going to set the chronology, and time flies, and if at the end we can't get all this material out, it will determine which are the ones that, to which I refer you to online videos. Okay, so I would like to have 3 TAs here. So I'd like Wade over there, and I'd like Aiden here. And drawing on his PhD in mathematics, I'd like Arash for sector 1. So sector 3, 2, 1. I would like to get votes, and I'd like each of you to calculate the number of hands up in your section. And then Arash, you will be put in charge of the computation of the final answer as a sum of the 3, okay? Is that good? Okay, that sounds great. Okay.
How many can you vote?
You can vote. You can vote. So I would ask you to vote with the following in mind. I could ask you, okay, you have 10 votes you can distribute among. Jeff, do you have any points of order? You've been MC many times.
Vote early, vote often. I guess you can vote for more than one, but realise if you vote for all of them, it's a lost vote. You need to discriminate.
Yeah. So maybe vote around 5 times. I don't know. Well, but then they could vote multiple times for one, and that will just get too complicated. Okay. Yeah. Just recognize that if you're use it to indicate things you're really interested in, not merely things that you're modestly interested in.
A vote for everything is a vote for nothing.
Yeah, okay. The Aussies have a lot to teach Canada and US about voting. They have their system quite right, I think. Good system. Okay, so sensitivity analyses and stochastics. Okay, Raj doesn't need the decomposition. Okay, 6, calibration. Okay, 5, okay, great. Dynamic networks. 4, okay. Model input output. The eyes have it. 9. Okay. Wow, Arash, you're really good at math.
Sigma of that.
What's that?
Of that sigma of all numbers.
Okay.
And then integral of that.
That's good. That's good. I'll let your former supervisor know. You've gone on to great things with your math skills. Okay. Any logic databases?
4.
Sorry?
4.
4. I thought I saw more than 4. Do that again. Raise your hands again.
I think someone
Yeah, right. Okay.
I think Sebastian, where you can count to 2.
Okay. Okay. So what's the count?
5.
5. Okay. Let's say 5. Okay. Trade-offs, distinctions, core competencies of different modeling types: discrete event, system dynamics, agent-based. When would I be inclined to use one versus the other? Okay. Okay, that makes it easy. Wow, that's great. We may have to sacrifice that one. Well, we'll see. I mean, it may be that we hit it tomorrow. Dynamic models and big data. 1. Okay. Okay, that makes that easy as well. So we'll put that towards the end. Implementation science and targeted interventions, representing them in the model. There's some sweet stuff there, I'll tell you. Okay. 4. Okay. Well, vote early, vote often. Okay. So 5. Okay. That's great. Okay. This helps us set our priorities. So, what we'll do this morning. So we have in contrast to previous days, we have a stiff constraint for lunch. We're very fortunate to be joined by the once and future queen, Yuan Tian, who will be giving a talk on some of her work with that falls under the rubric of the ED Weights and Patient Flow project here in the province. And she's also going to be joined by Graham Fast, who is serving as the key manager for that project and helping to drive it forward and as much insight himself. That will be today at 12:15. I'm committed to being over in the faculty club so that we can join them for that. And it's a stiff constraint. I don't have much opportunities to change it. They have schedule constraints. So we're gonna go through material, and that may mean there's a risk we may have to stop in the middle of an exercise break and then go to the faculty club, enjoy our talk, and then finish up before we go into project work. Today and tomorrow. Well, let me ask. Actually, I stand remiss, as is so often the case. By the way, I don't know. This disturbed me when I came in. A declining CDF. That doesn't. There's a CDF that went down like that. That doesn't. This is a cumulative distribution function. That scares me. There's something not right with the world if the CDF goes down. So CDFs should, by definition, they're cumulative. So and the probabilities are always between 0 and 1, so it should always go up. But anyway, well, maybe CDF meant something else. Maybe it meant, community distribution function or something. Okay. The other thing I'll ask for a final vote: project work, time for project work, okay? My own thought is to try to use about at least half of each day for project work. How many people are really interested in using project work time with the DAs, of course? Oh? Oh, okay. Okay. 3. Someone there? Okay, okay. Absentee ballot? Okay, okay. Okay. I'm trying to get my absentee ballot in place for the U.S. election. There's a certain urgency. Yeah. I was thinking about paying for 1,000 Uber drivers to drive from impoverished areas of LA to voting locations of their choice. Oh, okay. Well, yeah. Well, let's talk. Let's talk. Maybe we could get a model going. Okay. So anyway, though I suspect we'll be joined by many strong colleagues if it goes the wrong way. So. Yeah.
That's exactly what.
Yeah. Not that I like to contemplate. Okay, so ladies and gentlemen, we have a set of things. What I will do then is we're going to start with hybrid models. Okay. I'm committed to this, and I promised it to some people. Okay. And it seems talking about the U.S. election has made me terribly dizzy, so I'm going to have to sit down. Okay. Great. So, ladies and gentlemen, we're going to pause this now, and we will go on to our first lecture.